Hello, I am Dr. Gajendra Purohit. You are watching my YouTube channel where I upload videos for engineering mathematics BSc students. If you are preparing for any competitive exam where higher mathematics is asked, my YouTube channel is very helpful for you. I've just started discrete mathematics and today I will discuss with you what is a relation and how we determine if a relation is an equivalence relation or not. Because the concept here is reflexive, symmetric and transitive. How do we check it? I'm going to tell you all that. Before this, I have uploaded videos which you can find by going to the I tab. So students, let's start. First, we will talk about relations and what are relations. Whenever we have two sets given and there is a function defined between those two sets. So, when we have the set of the Cartesian product, that's a relation or not, right? In relations, you need to pay attention. There are three concepts that we have. One is reflexive, one is transitive, and one is symmetric. If we check whether the relation we have is one of these three, whether all three are present or not, if all three are present, then what do we call it? It is called an equivalence relation. For example, as I speak here, we have set A and we have set B, clear? In set A, the elements given are natural numbers like 1, 2, 3, 4, 5, 6 and 7. And here the set B we have is also a set of natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. This is given. Now the function we have defined here is y equal to x square. So we know that y, if we put the value of x as 1 here, then its square will be 1. If we put 2, what will be the square? It will be 4. If we put 3, the square will be 9. So the relation we have will be of what type? We will see here. So the 1 is going to 1, the 2 is going where? It is going to 4, right? Like this we have 3, that is going to 9. So this is our relation. Now this relation, this is what we have here. Is it reflexive, symmetric, transitive? How do we check this? I will explain this to you students. What is the domain and range of this? How do we know? For example, I want to tell you about this. These types of elements that we have are called domain. Elements that are connected to this, what do we have? It's a range. Here what will come in the range? 1 will come, 4 will come, then 9, 16 will come, 25 will come, then 36. What will we have? We will have range and all the elements that are here. Here are all the elements that we have. They come in our codomain, right? This is the codomain and the elements which are all connecting within this element are the range set. Clear, students? These are the things that we need to look here. I have already explained about domain and range here, that if we have two sets and both sets are related to each other by a function, then one is related to the other. So the elements of A are our domain and the elements of B which are connected to the elements of A, that is our range set. Clear? And rest of the elements that are there, they are our codomain. Here this relationship is given to us. You need to find out here what is the domain. The element at the first position will show the domain, like 1 and 2, that's the domain. And the element at the second position that we have here, what does it show? It shows the range, right? Now we will talk about the properties. That any relation that is given to us, is the relation reflexive here or not? So a reflexive relation means that a relation R is reflexive. If X belongs to A, then X must be in R. If X is in R, then that what we have here, it's reflexive. For example, suppose here 1, 2 and 1 to 3 has been given. If we have a relation which is defined from here, which is given as 1, 1, 2, 2 and 1, 3, right? Here you are seeing 1, 1. This is an element, so 1 should go to 1 and 2 should go to 2, right students? It is going right. Now 3 is not here, so 1, 3 extra it's coming along. So we have this. This means it will become reflexive. I will give one more example. Let's say here it is given as 1, 2, here it is given 1, 2, 3 and here we have what is given y is equal to x square. Assume this is given. Let's say 1, 2, 3, 4 is here. Now here when we put 1, 1 is going. If we put 2, 4 is going. So the relation that we get is 1, 1 is coming. Here it is coming 2, 4. So this relation is not reflexive because 2, 2 is not coming, right? If it's 2, then there should be another 2. If another 2, 2 would come, then relation we have here would become reflexive relation. So this type of relation which is not reflexive, we call it irreflexive relation. This needs to be kept in mind. Moving ahead, next we will talk about the relationship that we have, whether it's symmetric or not. So the concept of symmetry is, so if we have any element A, B is going to R, then B, A should also go in R. For example, here, if I say that 1 or 2 is right, and this is given to us. 1, 2 clear? Now from here we take 1, 2, 3 and 4 in here. Let's understand that, right? If I tell you that there's a relation given, we haven't defined any function. We have elements going here 1, 1, then 1, 2 going. Then 2, 1 goes, then 2, 3 goes, then 2, 4 goes, right? Like this way this is given, clear? So you can see here 2, 3 is coming. Now you can see if this relation is symmetric or not. You see 1, 1, if it's 1, 2, then 2, 1 should be there. Here 2, 3 is there, so 3, 2 should also be there. If you see 3, then it's not here, so 3, 2 can't be right, meaning the relationship is not symmetric. Yes, if by chance we only have these elements, only these elements are there, 1, 1 is going, 1, 2 is going, 2, 1 is going. What we have here, it becomes symmetric because 1, 2 and 2, 1 are inside it. This is what I was trying to explain here. Another example is given. This is 1, 2 and 1, 2, 3, right? If I take any relation here, 1, 2, 2, 1 and 2, 2. If it's 1, 2, then 2, 1 is also going. And 2, 2 is same element, so doesn't matter. So if AB, if 1, 2 is in R, then 2, 1 should also be in R. If this happens, then that is what we call a symmetric relation. We will discuss transitive relation. What is it? A relation R is transitive if X, Y belongs to R and Y, Z belongs to R. In that case, X, Z must also be in R. If that happens, then that is called a transitive relation. Let's take one more example. So students, let's say we have a set here, which is 1, 2 and another set given here is 1, 2, 3 and we have a relation R here. Where the elements given are 1, 2, we also have 2, 1 and 1, 1. We have this here. You need to figure out if this is transitive or not. So 1, 2 goes here, 2, 1 goes into it, and this cancels out. Remove this, so 1, 1 goes into it, right? If XY goes to R, YZ also goes to R. Then if we remove Y, XZ should also go to R. If we remove these two, then 1, 1 should go to R. If this happens, then such a relation is a transitive relation. I have another example of less than. If you want to know if this is transitive or not, if 1 is less than 2 and if 2 is less than 4, this one that we have, if it's less than 4. So what will be this relation? It will be transitive. So if any relation satisfies these three conditions, meaning it's reflexive, symmetric and transitive, then such a relation is known as an equivalence relation. Clear? Let me take an example here. So suppose I took a set here, right? You can see in this 1 and 2 and in B set we have taken here, which is given as 1, 2, 3, right? Now we have taken a relation here and we took that relation here like 1, 1. Then I took 1, 2, then we took 2, 1, right? If you need to find that this relation is equivalence relation or not, first you would check if it's reflexive. If we have 1, 1 here, meaning if 1 goes here, then it should be 1, 1. It's there, here is 2, 1 and 1, 2. See if 2, 2 would happen. This relation here, what happens? It becomes reflexive because 2 is coming inside it. So it means any element which is coming inside it, then that element's image should be there, right? So here if I do something, I remove it here, right? And I add 2, 2 in this, that means I take 2, 2 here, okay? Let's check what will be there. It will be reflexive, right? Now let's talk about symmetric. In symmetry, 1, 1 goes, then it's symmetric. 1, 2 goes, then 2, 1 goes symmetric. Here 2, 2, yes, we have this. We'll discuss on transitive or not. In case of transitive, whenever we have these two, we'll remove this. So 1, 2 is going. Yes, 1, 2 is going. We will see this 1, 1 is also in it, right? If we look here, you can see that all four of them. What are they doing? They are satisfying the transitive property. This relation will become transitive, meaning this relation we have, what will happen to it? It will be an equivalence relation. So in this way, we can easily understand this here. Now we will discuss some questions, students. First question we have is that A is equal to 2, 3, 4 and B is equal to 3, 4, 5, 6, 7, right? We are told to assume a relation R from A to B such that X, Y belongs to R when X divides Y. So X will divide Y, so what will we have here? That will be the relation, right? Let's take an example. Let's try to understand it with a Venn diagram. So students, here let's understand from the diagram. So this will be 2, 3, 4 and here this is what we have given 3, 4, 5, 6 and 7, right? Here this number 2, it is dividing where? 2 is dividing to 4 and 2 is dividing 6. So the relationship we get will be 2, 4, right? Here one will come 2, 6, right? Now we talk about 3. 3 is divided by 3 and 3 is divided by 6. So here what will we have? Listen here, 3, 3 and we will have 3, 6, right? Now we see that 4 divides where? So 4 only divides 4. So here 4, 4 will come, right? Now you will be asked on its domain. Whatever comes in the first position, that will be its domain. So which is coming first? It's 2, and how much is it? It's 3 and 4. So 2, 3, 4, what will we have here? Its domain, and then we'll talk about range. So what will be the range? So whatever we have connected, here 4 is connecting to it, right. Here we have 3 is connecting to it, right. 6 is connecting, this is not 0. So here 3, 4 and 6 will come right. Here what we have here, this will be its range. If someone asks, what is codomain? The codomain will be 3, 4, 5, 6 and 7, right? Now you have to find that if this relation is reflexive or not. If by chance you have to find, for it to be reflexive, 2, 2 should be inside it. It's not coming. 3, 3 is coming. If 6 is coming, then it should be 6, 6, right? So we need to see if this relation is reflexive or not. If it's 2, then 2, 2 should come, not coming. If 3, then 3, 3 should come, it is coming. If it's 4, then 4. Look, this is coming, this is coming. Here 2, 2 would also come, then this relation we have here would become reflexive, but this is not reflexive. If we need to find if this is symmetric or not. For symmetric, we have this, that if we have 2, 4, then 4, 2 should be there as well. But 4, 2 is not there. So this is not symmetric here. So here this will become transitive. Okay, students. Because here we have 2, 4, so 2, 4 is also coming. 3, 6 is here, so 3, 6 is coming. Now you will say 2, 6 is here, but it should be 6, 2, right? If it is 2, 6 and 6, 2, then we will see if 2, 2 should come. But it is not, so we don't need to look. Clear? Now we move on. Let's take more examples, try to understand. Show that this relation A, B, where AB belongs to Z and A minus B is divisible by 3, meaning A minus B is divisible by 3. So is this an equivalence relation or not? So first we'll talk about reflexive. So we know that if by chance reflexive means that A, A must be in R, which means we'll take same element means A minus A. So A minus A will be 0, and 0 that we have, it is divisible by 3, which means that A, A that we have, that will go into R, right? So this will be reflexive. Now we will talk about symmetric. So symmetric says that if A, A is in R, then here symmetric says if A, B is in R, then B, A must be in R. This means if difference between A minus B is divisible by 3, then difference between B minus A should be divisible by 3, right? If I tell 5 minus 2, 3 is there and divisible by 3. 2 minus 5 means that minus 3 comes, which is divisible by 3. So here this will be symmetric, right? We can understand it this way. Next we'll talk about transitive that we have here. So in transitive, what it means is that if we have AB in R and BC in R, then AC should also be in R. If the difference of two elements we have, and for these two, it is divisible by 3, then the difference between A and C must also be divisible by 3. Let's take an example. Let's assume I take this here 5 and 2. The difference, that is, what do we get? 3. It is divisible by it, right, students? So we see here that 2, 8, this difference is minus 6, which is also divisible by 3. This means that 5, 8, that should also go in R, which means that the difference should also be divisible by 3. So that is exactly minus 3, which is divisible by 3. Transitive property will be satisfied. If you want to prove mathematically, then AB and BC belongs to R. We know difference between A and B is divisible by 3. Difference between B minus C is divisible by 3. So if we add these two, then B to B gets cancelled out. Then it becomes A minus C, and then A minus C is what here? If this and this is divisible by 3, some will be divisible by 3. From this concept, we see A minus C is divisible by 3. This means A, C will go to R. This means that all three properties are satisfied. So R here will become an equivalence relation. Next question, what does it say? It's a very good question. If R be transitive and reflexive relation, which means R is both transitive and reflexive on A, and let T be the relation on A such that AB is in T. Here this means that T that we have is such a relation on A, where A and B is in T. Then only when AB and BA are in R, right? If AB and BA are in R, then what will we have for AB? It will be in T. If that's the case, you need to prove that. T we have is an equivalence relation. So first we will discuss if it's reflexive or not. For reflexive, we have the same element A, A, it should be in T. If A, A is in T, then by definition, we know that, students, it will be in T when it's A, B and B, A will be in R. Clear? So here this means that A, and A, because if A, A will be in T, then this it should be where? It should be in R. Because R, we have here it's reflexive. What is the definition of reflexive? That A, A should be in R. So A, because R is reflexive, then what will happen? A, A will go in R because R is reflexive. If it is like so, then this will go into T, which means T will be reflexive. The second point we'll discuss is about symmetric. What is the definition of symmetric? If AB is in T, then what should we have here? BA should also be in T. Now we know by definition. If AB is with us in T, pay attention here. If AB is in T, then what does it mean here? That AB and BA. These two should be where? In R, right? And if AB and BA are in R, then I can write them in reverse. I can write it as BA and AB in R. If that's the case, then listen what will happen here. BA will go to T. So AB is in T and BA is in T, which means this relation would be a symmetric relation. Now we'll discuss if this relation is transitive or not. Here we have to prove that T we have is transitive. If T is transitive, it means we have to prove this. We have to prove here if AB that we have is in T and BC we have is also in T, then it implies we should also have AC in T. Okay, right, students? This should be the case. We need to understand the definition. If AB is in T, it means that AB, comma BA, what should we have? It should be in R. Remember this definition. If it's in R, then it will be in T, right? So we will see here, if we have BC in T, what does it mean? BC and CB, what should we have here? Students, it should be in R, right? Now what we do is one by one we see them, right? I will take this one, I will take one AB and I will take this one. So this means that because these are also in R, these are also in R, meaning all four are in the R. So AB and BC, I will take these two here. If this is in R, this is in R and this is also in R. And R is given as transitive property. That means here, this AC here, it will also go in R by the transitive property, right? Now we are here, we are going to take this one and this one. So I am going to write this like this, CB first and BA, right? So here we have this with us in R because R is transitive for us. Then as B is here, this C will also go to R, right? Students, now we know that. For this AC here, we have AC, it is going to R and CA is going to R. If that happens, then in that case, what will happen here? If it happens, then AC that we have, it will go to T, right? If AC goes to T, then this will be easily proved as transitive here. Like this, we can easily prove this here, right, students? So look at the next question. If R is a relation on the set of integers such that AB belongs to R and 3A plus 4B equals 7n, when you add them, you get multiple of 7, where n is an integer, prove that R is an equivalence relation. So we need to prove that R is an equivalence relation. First, we'll take the reflexive. So we have A and B. We are going to show that A comma A goes to R. If I make it A comma A, then the result will be 7A. Ultimately, it's a multiple of 7. It's a multiple of 7. This means its reflexive will be easily done. Now let's talk about symmetric. Symmetric means that if AB is going to R, then BA should also go to R. If we have AB and BA, they should go to R. If this happens, the relation that we have, it will become symmetric. What do we take here? If AB belongs to R, then 3A plus 4B will be equal to 7n. Now we will prove that BA that we have is going to R. So in that case, we will write BA here. So we'll take 3B plus 4A, right? Now we can write this 3B plus 4A like this, okay? Here I wrote 3B as 7B minus 4B because the difference is coming as this. This is 4A. I've written it as 7A minus 3A. So this thing which is here, we'll write both of these here. In this, we have taken minus as common. It's given that it's the multiple of 7, right? This is multiple of 7 and this is also. 7 will be common, meaning this becomes multiple of 7. So this means BA will go to R. Now we need to prove that this relation, what do we have here? It is transitive. For transitive, what should we do? If AB is in R and BC is in R, then what will AC be? It will also be in R. This is very easy, we can do it. Look here, if AB is in R, then we will have this. If BC is in R, then we will have this. Now add these to this and this. So here we will have 3A and here we will have 3A, clear. Here 4B and this is 7B, we will do it later. This is 4C and when we add these two, it will be 7M plus 7N. Now what we do, we need to take out 3A and 4C because we need to show that AC is going to R. So this value that we have, we will move it over there. When we take it over there, this 7B will become minus 7B and 7 will become common. You see this is a multiple of 7. If it's a multiple of 7, it means that AC will go to R. What will happen here? It will be transitive. All three properties are satisfied with us here, meaning it is reflexive, symmetric and also transitive. This means that we will have an equivalence relation. So see here, we can easily prove this in this way, okay? If you want to watch videos of discrete mathematics, go to playlist on my new channel where I'm uploading videos and short tricks for IIT JAM CSIR NET GATE exam. You can go here and see my full playlist and subscribe to my new channel and follow me on Instagram. Thank you so much for watching. Like, share and be sure to subscribe to the channel. Press the notification bell so that you receive notifications of upcoming videos. Thank you so much.